Hello champions, welcome to the next lecture on the Legendre polynomial. Today's lecture is a very important if you are the students of the CSR NET, GATE or any of the competition examinations. The today's lecture is Fourier Legendre Expansion. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. What we have discussed so far, we have covered up to the 9th lecture, that is a trigonometry series of the Legendre polynomial. All these lecture you can find at my channel playlist name ordinary differential equation. As you can see, the trigonometry series, recurrence relation, orthogonal polynomial and many more lecture available in this single playlist. Now, if I ask you why there is a need of the today's lecture, fine. उससे पहले क्या आप बता सकते हो बच्चों कि फोरियर सीरीज का नाम आपने सुना होगा, फाइन. किस पर्पस के लिए यूज होती है और कब यूज करते हैं? अगर आपके पास एफ एक्स एक्स फंक्शन है तो इसकी हम फोरियर सीरीज कब लिख सकते हैं? एनी आइडिया? कब हम फोरियर सीरीज लिखते हैं, कब हम टेलर सीरीज लिखते हैं, कब हम पावर सीरीज लिखते हैं? तो फोरियर सीरीज सिर्फ और सिर्फ तब लिखते हैं जब हमें पीरियोडिक फंक्शन के ऊपर काम करना हो. फाइन. सो आई कैन अज्यूम अ पीरियोडिक फंक्शंस like cos x and sin x. Then you can write any function fx by using the expression a naught into summation an cos nx plus bn. तो आई उम्मीद करता हूं कि आपको अभी कुछ रिकॉल हो गया होगा कि ये वाला जो एक्सप्रेशन है वो किस चीज का है. एनीबडी रिमेंबर? यस, एब्सोल्युटली ट्रू. दैट इज कॉल्ड एज फोरियर series. Fine. So you can write any function fx as a linear combination of the cos and the sine. And how you can find the coefficient a naught, an and bn? You can easily find all these three coefficients by using the standard Euler's formula. Fine. Moreover, we also know the cos x and sin x follows the orthogonal property. Clear? That is brief idea about the Fourier. Now, since we also know the Legendre polynomial p and x also follows my orthogonal property, इसका हम proof already कर चुके हैं. You can see that orthogonal property of the Legendre polynomial. So, can you write? Can I say if I have the Legendre polynomial fx, p and x defined on the closed interval -1, such that p and x satisfies my orthogonal property. Always remember students, जब भी हम Legendre polynomial की बात करते हैं, that is a p and x, fine, that series is my convergent only for mod of x is less than 1. जब हमने इसका solution Legendre polynomial का solution निकाला था, वहां पे हमने proof करा था it is a convergent for mod x less than 1. That's why we always consider the domain is -1 to +1. Now, the question arises for you. Can you write fx as the linear combination of the Legendre polynomial and varies from 0 to infinity? Can you write the fx as a linear combination of the Legendre polynomial? If yes, then what are the coefficients values of c0, c1, c2 and then so on. Fine. So in order to find the value of the c0, c1, c2, we needed the concept of the Fourier Legendre expansion. Is it okay? Now, how we can define that? So consider the any function fx which are defined on the interval -1, which can be written in the form of the linear combinations of the Legendre polynomial. So my target is to find the value of the cn's, c0, c1, c2 and so on. So what I can do, I can multiply the equation number star with Legendre polynomial pmx and then integrate from -1 to +1. That means I can multiply the given equation by pmx and integrate with respect to -1 to 1. Fine. Now since I have to integrate with respect to x, so c and summation is a constant, I can take it outside of the integration and then I can integrate from -1 to +1. Now by using the orthogonal property, this value will be 0 if m is not equal to n, and this value will be 2 over 2n plus 1 whenever m is equal to n. Now clearly say your n varies from 0, 1, 2 up to the infinity. तो कहीं ना कहीं पे जाके बीच में m जरूर आएगा. फाइन, बिकॉज m इज माई फाइनाइट वैल्यू. तो जैसे ही m 0 होगा तो ऑर्थोगोनल m इज नॉट इक्वल टू n, तो 0 हो जाएगा. तो सिर्फ और सिर्फ एक जैसे ही m की वैल्यू n आएगी तब उसका आंसर क्या हो जाएगा, 2 over 2n plus 1. So I can substitute m is equal to n in this complete equation. So this is a pn. ये वैल्यू आपके पास क्या हो जाएगी, cn 2 over 2n plus 1 by using the orthogonal property. Now can you find the value of the cn? And that formula is called as Fourier Legendre formula. So that means whenever you can write any function fx into the linear combination of the Legendre polynomial, you can find the value of the cn is 2n plus 1 divided by 2 minus 1 to 1 fx into Legendre polynomial. Fine. That means if you want to find the c0, that will be 1 over 2 minus 1 to 1 fx. What is the p of 0? P of 0 is my 1. Similarly, if you want to find the c1, that will be 3 over 2 minus 1 to 1 fx into p1x. P1x is my x, and so. Fine. So once you have the fx, you can easily write in terms of the Legendre polynomial. Another very, very important result is, if fx is my special case called as a polynomial of degree m, then when you integrate from -1 to 1, that is this portion, fine, that will be 0 whenever m is less than of the n. For example, if your target is to find x की power 7 and n will be, let's say it's a 10, fine. So clearly say m is less than of the n, so that integration is directly as a 0. Similarly, if you want to find the x square of the p3x, that will again be my 0. Fine. Or otherwise, you can also say, let's say x into p2, that is also 0. How? You can easily prove that also. Like, what is the value of the p2? P2 will be half 3x square minus 1 into dx. So if you integrate them, that will be 0. Otherwise, you can see that number is my even function, that function is my odd function, and when you product them, the complete function is the odd function, and when you integrate from -1 to 1, it will be 0. Anyhow, if I write the function fx in the terms of the Legendre polynomial, because it has a degree m, so I can start from the m is cm pnx. Now I can multiply the equation number star with the pnx. Fine, because I need the value of fx is my xm. Fine, I can multiply equation number star with the pnx and then integrate from -1 to 1. Because m is not equal to n, it is given that. तो अगर m और n equal नहीं है, तो by the orthogonal property this value will be 0. Fine, hence you will get the required result. Now अब CSR net पे पॉइंट से कैसा इंपॉर्टेंस है? Can you write x square as c of n pnx? ये आपका क्वेश्चन है. n varies from 0 to infinity, but you can see the degree is my 2. तो इसका मतलब आपको ज्यादा से ज्यादा सिर्फ 2 चीजों तक ही निकालना पड़ेगा. प्लस c2 p2x. वाई? बिकॉज जैसे आप c3 निकालोगे तो इसमें क्या आएगा, x square p3x, यही आएगा ना आपके पास. एंड क्लियरली से 2 is less than 3. By the previous result, it will be 0. Similarly, c4, c5 and so on, all are my 0. Clear? So I will tell you the 2 different methods for solving the problem. The first method is, I can use the Legendre polynomial p2, p1, p0. I can find the value of the x square. That will be twice p naught x plus 1 divided by 3. I can find the value of the x, which is my p1x, and I can find the value of the 1 is p0x. I can substitute the value in the given fx. Given fx is x square. What is the value of the x square is 2 over 3 p2x plus 1 over 3. I can write 1 over 3 in terms of the pi's. So 1 over 3 I can write in terms of p naught. What does it mean? If you compare, that number will be my C0, that number will be my C2. Therefore, C1 will be 0 is the required result of the problem. तो आप देखो polynomial को आपने लिख दिया ना Legendre polynomial में. That is the first method with the help of the Legendre polynomials. Second method is I can express fx because it's a quadratic. I can write as a C0 C1 of P1x plus C2 P2x, where Cn is defined like this manner. So I can find the value of the C0, C1, C2. What is the C0? N is 0. That will be half minus 1 to 1 fx into P0x. Similarly, I can substitute n is equal to 1 and n is equal to 2. You will get the expression where fx is my x square. What is my p0 of x? It's a 1. So I can integrate them. It's a 1. What is the integration of the x square? It's a x cube by 3 from minus 1 to 1. It's a half 1 over 3 minus minus plus 1 over 3. So that comes to be 1 over 3. Similarly, what is a p1x? P1x is x. So if you multiply them, it's a x cube. So what is the integration of the x cube? x4 over 4 from 1 to minus 1, and clearly say that number will be 0. Fine. So the C0 is 1 by 3. C1 will be 0. Similarly, I can substitute. What is the P2? P2 is always be 1 over 2. 3x square minus 1. So that will be 3 by 4 minus 1 to 1 x square into 3x square minus 1. And if you integrate them, you will get the 2 by 3 is the right answer. I can substitute all the values in the given expansion. You can get the required linear combinations of the Legendre polynomial. और आप देखोगे दोनों मेथड से आंसर सेम आएगा. फाइन. लुक एट द सेकंड क्वेश्चन. सो फर्स्ट ऑफ ऑल, क्या ये fx आपकी पोलिनोमियल है? नहीं है. दिस इज अ केसेस है, तो यहां पे आपका फर्स्ट मेथड एप्लीकेबल नहीं होगा. फर्स्ट मेथड सिर्फ और सिर्फ तभी एप्लीकेबल होगा जब आपके पास कोई पोलिनोमियल होगी लाइक एक्स स्क्वायर प्लस एक्स प्लस 4 over 5 एंड सो ऑन. फाइन. लेकिन मैं हमेशा रिकमेंड करूंगा यू कैन अप्लाई द मेथड नंबर 2. सो आपका टारगेट क्या है? ये फॉर्म में लिखना. तो बिकॉज इट हैज ए केसेस, सो आई कैन ब्रेक -1 to 1 -1 to 0 and then 0 to 1. -1 से 0 में अंदर fx कितना है? 0. so that will be 0, and from 0 to 1 it's my 1 into p and x. Clear? अब आप इसमें substitution. Now your target is to find the value of C0, C1, C2, C3, C4 and so on. क्योंकि ये polynomial नहीं है तो आपको infinite series तक लिखना होगा. तो C0 की वैल्यू कितनी आएगी? हाफ 0 to 1 p naught x. Similarly, C1 is 3 by 2 0 to 1 p1 x. Similarly, C2 is 5 by 2 p2 and then so on. What is the p0? P0 is my 1. So if you integrate them, that will be 1. So that will be half. What is the p1x? P1 is my x. If you integrate x as a x square by 2 from 0 to 1, that comes to be 3 by 4. Similarly, you can substitute the value of the p2. What is the p2? P2 is half 3x square minus 1. So that comes to be 5 over 4. If you integrate them, 3x square, that is the x cube minus x from 0 to 1. So that will be 0. Fine. What is the p3? P3 is my 1 by 2 5x cube minus 3x. So I can do that 7 by 4. I can integrate the x cube. So it's a 5 x4 by 4 minus 3 over 2 into x square from 0 to 1. So I can solve them 7 by 4, 5 by 4 minus 3 by 2. So 10 minus 12. 10 minus 12 is a minus of 2. Minus 2 will be cancelled out. So that will be minus 7 over 16 is the required expression, and so on. Fine. So I can substitute all these values into this expression. C naught C1 P1 plus C2 P2, because C2 is my 0. So your final answer will be C naught plus C1 into P1x plus C2 will be 0, C3 into P3x plus, and so on is the required expression of the Legendre polynomial. So these 8 questions as an exercise for you. This you can apply only as a second method, because these are the polynomial you can solve either by the first method and the second method, and you can check by both the method, answer must be same. Let me know your answers, all these answer in the comment box. We will see the next lecture very soon. Till then, you can share this video, like and comment on it. Happy learning, students. Best of luck.